All right, 7.2b volume. We're going to call this revolving around the y. Yesterday, we started revolving around the x-axis. All right. What were you in terms of when we revolved around an x-axis?
X.
We had to be in terms of x. So on this one, we're going to be revolving around a y-axis. Not necessarily always the y-axis, but a y-axis. And so what do we need to be in terms of? Y when we do that. All right. So Evan's going to read for us.
Find the volume of the solid obtained by rotating the region bounded by y equals x cubed, y equals 8, x equals 0 on the y-axis.
All right. So it's going to be bounded by those things. And then we're going to revolve it around the y-axis. So let's draw our picture. All right. These are very difficult to do without drawing a picture. So what does x cubed look like? Very good. Whoop. All right. And then y equals 8 is a what kind of line? A horizontal line going like that. And then x equals 0 is also known as the y-axis. So that is bounded right here. So I'm going to be taking that portion and I'm going to be rotating it about the y-axis. So that's what your picture should look like. Does that make sense? All right. And if you wanted to see your CAD drawing kind of thing from it, there it is. All right. So it's kind of like a bullet again. All right. So I need a radius, right? But I need to be putting it in terms of what? Y. So let's solve for x. So what does x equal? The cube root of y. And I'm going to call it y to the 1/3. Okay, yes, that is cube root y. However, when we start working with it, I think it's a little bit easier with these. All right, so is this a disc or a washer? It's a disc because there's no gaps in this one. All right, so it's going to be a solid 3D shape. So my big R of y is just what? Y to the 1/3. All right, so it's this portion right there. That's all it is. So my integral, what's my lowest y value? 0. And then what's my upper y value? 8. All right. And then what goes out front? A pi. And then I have y to the 1/3 squared. Because essentially I'm taking an integral of a circle. It's pi r squared, right? So let's do a little bit of math. Y to the 1/3 squared is really y to the 2/3. And I'm going to go from 0 to 8 with a pi chilling. So now let's anti-derive it. I got a pi out front. And then now I have a y to the what? Add a power. What we at? 5/3. And then we multiply by. So now we have 3/5. And I'm going to go from 0 to 8. So now I'm going to substitute in 8. All right. So when I substitute in 8, I would not do it to a power of 5 and then cube root it. Let's cube root it first. Let's make it nice little easy numbers. So I cube root 8 and I get 2. 2 to the power of 5 is 32. So now I have pi out front with a 3/5 times 32 minus, when I substitute in 0, what do I get? 0. And then let's put a couple things together. 32 times 3 is 96 pi over 5. All right, pretty good? All right, let's do another. Evan, pick somebody. TJ, read.
Find the volume of the solid formed by revolving the region bounded by the graphs of y equals x squared plus 1, y equals 0, x equals 0, and x equals 1 about the y-axis.
All right, so we're going to revolve it around the y-axis again. All right, let's draw our picture. What's x squared plus 1? Parabola. Where does it start? It starts at 1. So we have a parabola that starts at 1, kind of like so. And then we have y equals 0. That's known as what? The x-axis. X equals 0, known as the y-axis. And then x equals 1, which is just a vertical line over here. All right? So I'm taking this portion and I'm revolving it around the y-axis. So that's what your picture should kind of look like. All right. So if you want to know the CAD drawing, there it is. However, if we're revolving around a y-axis, what do we need to be in terms of? Y. All right. So let's solve for x to put it in terms of y. So what does x equal? Square root what? Y minus 1. We subtract 1, we square root it. All right. Now, technically, it's plus or minus, but which portion are we dealing with? The positive square root. All right, because we're in the first quadrant. All right. Now, this one's a little bit tricky. Is this a disk or a washer? It's both. This one's both. Because from this portion would be a what? A disk. This portion would be a washer. So how many integrals am I going to have to use here? I'm going to have to use 2. So let's do it. So now I'd have an integral from, let's do my disk first. Let's do the bottom portion. So what would be my lower limit? 0. And what's my upper limit? 1. I have a what out front? A pi, because it's pi r squared. And then what's my radius here? What is my right minus my left? What is my right? 1 minus 0. So I have my radius of 1. And I'm going to square it. Doesn't really do anything on that one, though. All right. And then I'm going to add it. And now my next integral is going to have a pi out front. And then this is going to be a what method? A washer. So I need to know my big R of y, and I need to know my little r of y. So my big R of y is that portion right there. So what would that big R of y be? 1. All right, it's 1 minus 0, which we're going to call 1. So then we need to get to our little radius, and our little radius is this portion right here. So what's my little radius? Square root of y minus 1. All right, because we're in terms of y. All right, it's really minus 0, but we don't need that. All right, so what are my limits? What's my lower limit here? 1. What's my upper limit? How did we get it? How did we get 2? We substituted in right here. All right, because it's bounded by x equals 0 and x equals 1. If I substitute in 0, what do we get? We get y equals 1. If I substitute in 1, we get y equals 2. So that's why it's bounded by 1 to 2 right there. All right. So then I'd have my big radius of 1 squared minus my little radius of square root y minus 1 squared dy. This is where I would not skip steps. All right, let's work with the left side first. This will be easy. So what do I have? I have a pi out front, and then what? What's my antiderivative of y 1 squared? No, it's not x. It's what? Y. All right, why is it y and not x? I'm in terms of y. Be respectful. All right, and then we go from 0 to 1. All right, here we go. So we get pi, and then what? Times 1 minus 0. All right. All right, so let's FOIL on this side. Actually, we don't need to FOIL. We just square it. So now we have 1 minus the quantity of y minus 1. What would I highly suggest you do over here? Pew, pew. All right. So then we have the integral from 1 to 2 with a pi chilling.
2 minus y.
2 minus y dy. All right. I see some students a lot of the times like just try to cancel out ones because they don't do what?
Star products.
They don't distribute that negative. All right. So now when we antiderive, good. All right. So now we're going to substitute in 2. And so we end up with 4 minus 2, and then minus, we substitute in 1, and we get 2 minus 1/2. What would I highly suggest you do? All right. So this portion cancels. So what are we left with? 1/2 pi. So I have pi over here. I got 1/2 pi over there. How many pi did I got? 3/2 pi. All right. So the volume, whatever that is 3/2 pi. All right, pretty good? All right, let's keep. Here we go. Who is called upon? TJ, pick somebody. Quickly.
Elijah.
Go.
Find the volume of the solid obtained by rotating the region under the graph of f of x equals 9 minus x squared, for 0 is less than or equal to x, which is less than or equal to 3. About the x-axis for x equals negative 2.
The axis x equals -2. All right. So let's draw it. So 9 minus x squared, what's it look like? 9 up, and then what? It's a parabola going down. All right. Now, I'm only going to draw it to the right because it's from 0 to 3. You following me? All right. So that's why I'm drawing it there. And so that's where it's bounded by. That's its bounding. And then it's rotating about the line x equals -2. What kind of line is that? Vertical line. It's a vertical line. All right. And so it's rotating it about that. All right. Now, does that have a gap in between where I have my area and I'm rotating it about? It does have a gap. So what's it going to be? It's going to be a washer. All right. It has a gap. All right. So we need to figure out first of all, what kind of axis is this? It's a y-axis. It's a vertical axis. I like to call them a y-axis. It's not technically the y-axis. So what do we need to put it in terms of? Y. All right. So let's do it. We subtract y. We add x squared. We square root it. We end up getting x is equal to square root 9 minus y. All right. So let's keep moving. So what's my big R of y? Okay, remember it's always right minus left or top minus bottom. In this case, it's right minus left. So what's my big R of y? Square root 9 minus y, and then what? Minus -2. So I end up having square root 9 minus y plus 2. Okay? All right, so then we need to get to a little r of y. So my little r of y is the stuff that I'm subtracting out. All right, that's the stuff I'm taking out. So what would it be? It would be what? 0 minus -2. So I end up with 2. All right. Now, it totally gives me my bounds on this one. So let's set up my integral. So I'd have a pi chilling out front, and then I'm going to go from what? 0 to 3. And then my big R of y of square root 9 minus y plus 2 quantity squared minus 2 squared with respect to y. All right. Why is it with respect to y? Because it's rotating about a y-axis. All right. And I usually solve this one, but for the sake of this shortened period, I'm just going to say you did it. We got 225 pi over 2. Good job. All right. And I think it looks like either an angel food cake or a bunk cake, which I like both of them. All right.
All
All right, just kidding. It is not 0 to 3. Did it right last time. What are we in terms of, guys? It's in terms of y. So what are we in terms of? It's in terms of y, so we need to go from 0 to 9. All right. All right, Josiah's reading. R.
That's R?
Enclosed by the curve y equals x and y equals x squared is rotated about the axis x equals -1. Find the volume of the resulting solid.
All right, let's do it. So we have y equals x. What's that look like? There you go. Y equals x squared. What's that look like? Very nice. All right. And so that's my region bounded right here. And what am I rotating it about? X equals -1. So my axis is over there. And that's what I'm rotating it about. So is this going to be a disc or a washer? It's going to be a washer. And it's rotating about the line x equals -1. So is that an x-axis or a y-axis? It's a y-axis. All right, so what do these need to be in terms of? Y. So y equals x is really what? X equals y. Y equals x squared is really what? square root y. All right. So let's do it. So let's see what my integral is from. Well, how do we figure out what my integral is from? We do what? We set them equal. So we'd have y is equal to square root y. So when do we get that? 0 and 1. Now, if you did it purely math ways, you're going to get negative 1 as well. However, that's a what kind of solution? Extraneous. All right. All right, so what goes out front? Pi. I'd like you to build your big R of y and your little r of y. So what is your big R of y?
Square root of y plus 1.
There it is. No, I don't want you to say that. Square root y and then what? Minus negative 1. Yes, I know some people can jump straight to it. However, I really do want you to always do right minus left, top minus bottom. All right. All right, and then what's your little r of y? Y minus a negative 1. So we can simplify that to y plus 1. All right. So I have the quantity of square root y plus 1 quantity squared. And then what? Minus the quantity of y plus 1 squared dy. All right. And then we go ahead and math 9 that, and we end up with pi over 2. Okay. And there's the CAD problem. All right, so there's your homework. Now, all I want you to do is set up the integrals. All right, set them up. Find your big R of y and find your little r of y. I want you to work on 41 through 48 first.